Well, maybe can we wait for 1 minute?
Yeah, sure, uncle. We'll wait for some time.
Yes, Manish, we can start. Let them join in due course.
Okay, uncle. Yeah. Once again, good evening, students. It's great to have all of you on board. Okay, so we are now advancing forward. So we have covered a couple of chapters. Two chapters have been covered. So now we are moving on to the third chapter, okay, of NCRT, which is motion in a plane. So we'll be looking at this. So again, this is going to be the basics. So we'll be brushing up the basics, and then we'll solve questions based on the competitive exams point of view. That is what is planned. So we look at some basics, some ideas. You definitely might be familiar with. Okay, so let's start off without any further delay. Okay, so some basic concepts of, first we'll talk about scalars. Okay, so what is meant by scalars? So some of you might definitely be knowing. So those physical quantities which only have magnitude and there is no specific direction associated with them, then we call such physical quantities as scalar quantities. Okay, so they are called as scalars. So to understand this, so the physical quantities that have only magnitude, associated with them. Okay, that have only magnitude associated with them are called as scalars. So many examples you can give for scalars. So there are different examples. So you can be thinking of speed as a scalar, right? Because when you talk about speed, it only gives me the information of how fast an object is traveling. Rather, I don't have information about the direction in which the object is traveling. So that is what is speed. Okay, it's a distance upon time. And then time is also a scalar, right? It only tells you the duration or the interval between the happenings of any particular event. So time is a scalar quantity. Temperature is again a scalar quantity. So like this, you have different scalar quantities. You can talk about mass is a scalar quantity, etc. Okay, so these are particularly called as scalars because they only have magnitude associated with them. You only have a particular value, but you don't have the information about the direction, okay, of any particular value that we are talking about. So that's all about the basic aspects of scalars. Second, you have vectors. Now vectors, in fact, they are physical quantities which have both magnitude as well as direction. So you have both the association of magnitude and direction. You can simply call them vectors. Okay, so these physical quantities, okay, we can make it those. So those physical quantities which have both magnitude and direction associated with them are called as vectors. So any examples of vectors? So many examples are there in real life. So when you talk about vectors, you can say velocity. Okay, although velocity and speed share the same unit, but they are different. Speed only talks about how fast an object is moving, but velocity tells you, along with the information of speed, you also have the direction of travel of the object. So that's the difference between speed and velocity. So velocity being a vector, you also have acceleration, you can say displacement. Okay, so like this you have different examples, children, wherein you have both direction associated with magnitude. So that's the idea about scalars versus vectors. So you just need to have a subtle idea between these two physical quantities before we proceed any further. So having understood the differences between scalars and vectors, now we move on to the representation of vectors. So we get into the topic of vectors. So we try to understand how to even represent a vector. Okay, what are the different ways of representing them? So we'll see that. Third, you have representation of a vector. Okay, so we are going to see how to represent any particular vector. How do we do that? For instance, I want to write a vector, I want to express a vector. How do I express it? We express vector like this, using capital letters. Okay, generally capital letters are used, so it's an uppercase letter, so we call this as vector A. Okay, so we represent using an arrow mark on top of the capital letter that represents any particular vector. So we just call this as vector A. So the arrow mark is representing the direction of travel of the vector, so it just shows that it's a vector quantity. So if I say vector A is equal to ax I cap plus ay j cap. Now you can see that I have used two different notations here. Okay, so I'll tell you what is what. So this is the vector notation. So you name this as vector A. Now what is ax? Ax is basically, it is the component, it is the x component of vector A. Okay, ax is basically the x component of vector A. And can you see that there is an I cap? What does this I cap represent? So I cap is representing the unit normal vector along x direction. Okay, so in physics, instead of saying x, y, and z axis, so here we would say I, j, and k. So generally in maths they use the notation of x axis, y axis, and z axis. But here we'll be dealing with I, j, and k, where I is the unit normal vector or unit vector along x axis. Similarly, j is the unit vector along y-axis. Okay, and what about ay? Unlike ax, ay is the y component of vector A. So it's the y component of the vector. So this is a fundamental representation of a vector. Now you can see this vector A is having two components, one x component and one y component. So what category of vector does it fall under? We call this vector A as a two-dimensional vector. Okay, because you have only x and y. There are only two dimensions. So this is a classic example of a 2D vector. Okay, so vector A is basically a 2D vector, a two-dimensional vector. Am I clear? So this is how you represent any particular vector. This is the basic aspect of how a vector is typically written, or it is expressed. Okay. Now, having understood the basic representation, let me see if you're able to interpret the data from a given vector. For instance, Okay, for example, say I'm writing vector x is equal to 2i minus 3j. Okay, 2i cap minus 3j cap. Now, who can tell me what is the x component of this vector? Okay, so what is the x component from this given vector? It's easy to identify. Just you need to interpret the data from the given vector. So tell me what is x component and what is the y component. Yeah, you can answer. So what's the x component, children, from the given vector you can identify? Yes, quite simple. It's nothing complicated here. Feel free to answer. You can unmute and then you can say x component and y component. Yeah, somebody is trying to tell. I'm not able to hear.
X component is 2 and Y component is minus 3.
Very good. X component is 2 and y component is minus 3. Great. Okay. So that's how you interpret the data from a given vector. Very nice. So with that, we'll move on. So we know how to write a 2D vector. Now, unlike the two-dimensional vector, how to represent a three-dimensional vector? Any idea? So say I'm writing vector B. So how should I modify vector A such that I want to write vector B as a three-dimensional vector? Anybody? You just have an additional term, right? So you need to include the z-axis as well. So we'll write it as ax I cap. I mean, here we can write B because I've used vector B. So we'll use B notation. So we can say bx I plus byj plus bz k. So you can see that here, this is a three-dimensional vector because you have an additional axis called z-axis. So this is an example of a 3D vector. Is that clear, children? That's how you represent, a 3D and a 2D vector. A 2D vector will have two dimensions, ij. A 3D vector would have three dimensions. Additionally, you have a k cap, which is unit normal vector along z-axis. Okay. So on that note, we will proceed further. We have learned now the basic representation of a vector. So with that, we are moving on to the next part. Let's see how to find out the modulus of a vector. Okay. Modulus of a vector. Sometimes this is also called as magnitude of a vector. Okay. Magnitude of a vector. So let us see how to find out the modulus of a given vector. Okay. Suppose the given vector is, say, I'm taking vector A itself. So if vector A is written as ax I plus ayj, okay, then modulus of the vector is written as, you put two parallel lines and you put A in between. This is called as mod A or modulus of A. Okay, and the formula to find out the modulus or magnitude of any particular vector of a given vector is under root of ax squared plus ay squared, and that's the formula to find out the modulus. Okay. Similarly, if you take another vector, a three-dimensional vector, say vector B is bxi plus byj plus bzk. Okay, if you have a vector like this, then modulus of B can be written as mod B equal to sum of the squares of the components. You can see I'm writing just the under root of sum of the squares of each and every component of I, j and k. That's what we are doing. So that will fetch us the modulus of any particular vector. So here mod B would be under root bx squared plus by squared plus bz squared. And that's how you evaluate the modulus of any given vector. Okay, I hope I'm clear. So this is how you identify the modulus of any given vector. Now, come on, let's try to identify the modulus of a vector. A simple, question for your understanding. Okay.
Manish,
Evaluate.
I just have a doubt. Is modulus always
Yes.
positive?
Modulus is always positive. Yes, it is positive
So children, you
because
should
we are,
understand this. Why it is positive, children? You think over it. Okay, you need not
yeah,
give answer. You think over it.
okay, yes. So here, children, that's what we are going to see as sir, asked. So you'll itself get the answer for it as we, look at different examples. So we'll look at it. For example, try to evaluate the modulus of minus j plus 2k. Okay. Now I've given you a vector and you have to evaluate what is the modulus of this particular vector. Okay. Let's name this particular vector as, say, vector c. So vector c is given as minus j plus 2k. And now we will have to calculate what is the modulus. So anybody, you can tell me the first step, what would you do? Here you identify first what are the components given in this vector c. You should be very careful when you try to interpret the data from a given vector. Okay. So here we want to find out what is mod c. Yeah. So what do we do? Obviously you take under root and then you will have to substitute the values. So who can tell me what is cx here? That is x component of vector c. Anybody? So look at the given vector carefully, analyze, and then try to interpret. So what is the x component of vector c? It's okay even if you're wrong, it's fine.
X component is 0, sir.
Very good. X component is 0 because you cannot find I cap itself there. So there is no x component here. That's correct. Absolutely right. Okay, what about y component? Yeah, what's the y component?
It is minus 1 and plus 2 for Z component, sir.
Yes, that's right. So it's minus 1, the whole squared plus then z component is 2 the whole square. I hope you're getting the answer to the question that sir asked. So will this be positive or negative? The overall answer for this? So what's the final answer, children? Yes, it is positive. And what is its value?
Root 5.
Yes. So root 5 is the answer. So the magnitude of vector c is root 5. And why do you think it's positive? You can see that you're taking the squares, right? So even if you have negative values, they will ultimately become positive. Okay, because negative times negative is obviously going to end up giving you positive value. So there is no way that you would get a negative magnitude. Okay, it's fine. So let's move on. So I hope modulus or the magnitude of a particular vector is now clear. On that we will move on to the next part. Okay, so proceeding further, now we have a unit vector. So let's see how to calculate, how to find out a unit vector of a given vector. Okay, so a unit vector, you want to calculate or determine what is the unit vector of any particular given vector, and how do we do that? Okay, unit vector which is perpendicular to a given vector. So when you try to find out a unit vector of any particular given vector, we represent the unit vector using a cap. Now what do I mean by a cap? This symbol is called a cap. You remember I have written I cap, j cap and k cap. Can you see over I there is a cap like symbol which looks like the roof of a hut? So that's what is called as the representation for unit vectors. So you put a cap on the top. So here, if I want to find out unit vector of any given vector, I call this as unit vector of A. When I put A and put a cap over it, so A cap is nothing but unit vector of vector A. And how do I find that out? It is given by the relation unit vector of A is equal to vector A upon modulus of vector A. So by using this relation, you can find out what is the unit vector of any particular given vector. Okay, this is the simplest way of evaluating what is the unit vector. So you can try to do it for different types of questions. So first one, I'll just give you some questions. First one, try to find out the unit vector of, I'll give you vector A, 3i minus j, and then unit vector of, okay, now I have another vector. I'm giving you vector r as, okay, 2 sine t I minus 2 cos t j. So I've given you two vectors, children. For the first one, it's general, vector representation. The second one is a trigonometric representation. Okay. So because there are different variety of questions that can come, and that's why I'm addressing to different types of functions. So first one, vector A, what is the value of A? So write it out and tell me what is unit vector of A for the first part. For the given R, you can calculate A cap, substitute, simplify, and get back with the answer, how much you're getting. So numerator, what you need to be writing, and in the denominator, what you need to be writing. Okay. So what is A cap? You can do it along with me. So along the numerator, what should you write? It's vector A, right? So vector A upon modulus of vector A. Use the formula. So vector A, from the first part, we know that it is 3i minus j upon modulus of A. And you know the formula? Under root of 3 squared plus negative 1 the whole squared. Okay, and what is the answer? You can write this as, so the root value you can simplify it first. So I hope you will be getting root 10, right? So it is 1 upon root 10 times 3i minus j. So that's the value of A cap. Okay, the unit vector of A. Okay, so this is how you do the, so this is a solution for the first part, that is evaluation or determining what is the unit vector of a given vector. Now who can tell me what is R cap? For the second part, what is the answer? First one we have done. For the answer for the second part, let me just make it 2. It's not 3. Yeah, so second part answer, that's for R cap. You can try it out, children. So it is again vector R upon modulus of vector R. So you need to express its modulus. Yes. Now in the numerator, substitute the value, denominator, evaluate its modulus, and then simplify it. Yeah, anybody? What is the answer for the second part? Yes, one of you can try. Tell me the numerator and denominator terms, children, and then let us try to evaluate it individually. Go ahead. Feel free to answer. Don't hesitate. Yes, children, I'm always there to help you guys out. So feel free. We are learning. Yes. So vector R upon modulus of vector R. Anybody is ready with the answer? You can give me the answer as well. Yes, Tatvadika, can you do it? Any idea? Okay, so feel free, children. It's fine. Even if we do mistake, it's okay. Otherwise we can't learn. So vector r upon modulus of vector r. So here we are substituting. Yeah, somebody was trying to answer. Yeah, it's okay. You can answer. Yes, go ahead.
Yes, sir. 2 sine uh,
Huh.
2 sine t I cap minus 2 cos t j cap by
Yes.
uh, 4 sine square t plus 4 cos square t.
Uh-huh.
Taking inside root and it becomes 2, and the sine square t plus cos square t is 1.
Okay. Okay. Yes. So that's how you do it. Great. Okay. So in the denominator you have again 2 square sine square t. So 2 square is 4. So I can write it as 4 sine square t. Here also you get plus 4 cos square t. And simplifying it, children, you will be getting. So in the numerator also you can see you can take 2 as common out, right? So 2 times sine t minus cos t. So you have it. Sine t I minus cos t j. So you can put that also. Okay, so express it. So just write it because there is less space left. So 2 within brackets sine t I cap minus cos t j cap. Okay, upon. Now here, as one of you rightly said, you can see that 4 can be extracted out of the root as 2, isn't it? So it comes out of the root, and under root of sine square plus cos square is 1. So I think it's 2 into 1. Okay, I hope all of you agree with me. So by using the trigonometric identities, and here 2 and 2 will get cancelled, and finally what is your answer? Your answer would be r cap is equal to sine t I minus cos t j. That's your answer, children. Okay, that is how you calculate it. So this is how you calculate the unit vector of any particular given vector. So I hope this is clear. That is the reason I chose 2 different aspects, 2 different types of vectors. One is trigonometric and one more is the general method of representing it. Okay, so you can have different types of questions coming from these vectors point of view. So you will have to practice such questions basically. Okay, so on that note we'll proceed further. We'll go to the next aspect, sixth one. Next the number is 6. I hope this is clear. Okay, so having understood what is modulus or magnitude, and then what is the unit of a given vector, unit vector. So with that we move on to the next aspect. Okay, now
So,
we have, yeah, yes,
so can you show the previous slide 1 minute?
sure.
Sir, in
Yeah.
that A vector is equal to 3 I cap minus j cap. The question,
Hmm.
in that instead of 3 I cap, we can write as a 3 I vector, because in state board we used to use it as 3 I vector also. So,
Yeah, you can.
okay, sir, 3 I cap and 3 I vector are same.
3 I cap and 3 I vectors are same because 3 I, the way they printed in the state board textbooks, they use a bold letter and print it. Okay, so that's fine. Representation might be different, but ultimately the meaning is the same. Okay, it has the same sense. All right, yeah. Okay, so I hope that's clear. We'll move on to the next part. So we have looked at some basic aspects, children. So now with that we are proceeding further, okay, to the next aspect. So here we will be learning about scalar dot product of vectors. Okay, scalar dot product. So the scalar dot product is also having a great significance as far as vectors are concerned. So you need to understand how to deal with scalar dot products, and how to find out the values of scalar dot products. Okay, so we'll try to understand this particular aspect. Now anybody is having any information about idea about scalar dot product also, you can definitely share. Okay, and you can tell me. So whenever we say a scalar dot product, okay, so how do we represent a dot product? Let us see. Okay, so here, so scalar dot product is basically an algebraic method of, or you can say an algebraic operation, which is used to find out what is the product of any two given vectors. So it goes like this. Okay, so we can say vector A dot vector B. So when I put a dot in between, this dot denotes the algebraic multiplication of two vectors. So this, I call it as vector A dot vector B. That is how you call this. That is how you name it basically. Okay, that is how it is represented. So vector A dot vector B can simply be written as, by summation, I can say, write it as sigma I is equal to 1 to n AI and BI. So because I'm using capitals, let me also stick with capitals. Some textbook use small letters also. So need not worry children, both are one and the same. So vector, it is sigma I equals to 1 to n AI and BI. Okay, so this is the representation, and the formula for scalar dot product of vectors. Now, there are some rules that you will have to keep in mind whenever you evaluate scalar dot product. What are the rules? You know that every vector is having a unit normal vector I cap, j cap, k cap. Okay, so I, j, k can be there. For some vectors, only I and j might be there. It depends. Now, when you multiply those unit vectors, what are the values that you get is very important. So for scalar dot product, the rules that you need to keep in mind is I dot I equals j dot j equals k dot k, and this value equals 1. It equals unity. So always, like unit normal vectors, whenever you take the dot product, okay, when you evaluate them, you will end up getting 1. Okay, so this, why is it 1 also we are going to understand. In the meantime, you will understand why it is 1. Okay, so this is the first basic rule that we apply. Now I gave you the formula here. There is one more particular relation as well for vector A dot vector B. This is a general formula that I have given you. Okay, now scalar dot product vector A dot vector B, suppose they are making an angle theta with them. Previous formula is applicable if there is no angle given to you. You don't have information about angle, then you will use the previous formula. That is the first formula. Second formula is applicable when both of them are inclined with a particular angle. Then you can make use of this formula, which goes like this: vector A dot vector B is equal to modulus of vector A times modulus of vector B times cos theta. Now what is theta? Theta is nothing but the angle between vector A and vector B. So that angle you call it as theta. So when you try to represent these two vectors, you can represent them like this. So say this is vector A and this is vector B, and the angle between these two vectors, we can take it as theta. Then this formula is applicable. So dot product can have two different ways of evaluating them. First evaluation, you just have two vectors, no information about angles, you can directly use them. Second, in case there is an angle relation, you can make use of the second formula. So purely depends, okay, on the way it has been evaluated and the data sufficiency of the question. You will wisely choose whichever formula needs to be used. Okay, so these are the two different aspects. Now coming back and answering the question of why I dot I, why j dot j, why k dot k is equal to 1. Okay, so I hope you guys are aware about cos function, cos theta. In maths, cos theta is having some initial value. there is a finite initial value. Is it an increasing or a decreasing function? If you try to analyze, you know that the domain and range of sine is different, and for cos also it is different. Sine value starts from 0 and reaches a maximum value at sine 90, which is 1. But unlike cos value, it starts from 1. By the time it reaches sine 90, it is going to be 0. I hope I am clear with that. Cos. When I say cos 0, I think you guys know cos of 0 degrees is equal to 1. You agree? And that is how it goes. Okay. And cos 90 is going to be 0. As per trigonometry, I am speaking. Fine. Now, when I say I dot I, now don't you think both the axes, both the unit normal vectors, don't have any angle of inclination theta? So, therefore, here theta is going to be equal to 0 degrees. If theta is 0, don't you think I dot I, if you're going to evaluate the dot product, you will be ending up getting the value as 1, because I, its component is going to be 1 because it's a unit vector. What do I mean by a unit vector? Whose magnitude is going to be unity. It's just 1. So therefore 1 times 1 into cos 0 degrees. That will fetch you the answer as 1. Same goes with j dot j. Same goes with k dot k as well. Okay. That is the reason I dot I, j dot j, k dot k is 1. Okay. Now what about I dot j? What will be its value? If I take I dot j, if I take j dot k and k dot I, you know that angles between these vectors is 90, and cos 90 is going to be 0, and hence the answer for all of these is going to be 0. So unlike unit normal vectors, dot product will end up giving you the answer as 0. So that is the reason, unlike unit normal vectors, we are not considering. We only consider the like unit normal vectors. Okay. So that is how, these are the two important rules that you need to keep in mind before you evaluate scalar dot product. Okay. So on that note, so we'll proceed further. I hope scalar dot product of vectors is now clear, and what are the two different aspects of evaluating or determining them, that also I have explained. So with that, we'll proceed. Let's look at some examples now. Okay. So you can try and tell me what are the scalar dot product examples. I'm giving you two vectors, children. Vector A equals to minus I plus j minus k. Vector B is equal to 2i plus 3j minus 2k. Okay. So what is the value of vector A dot vector B? So how will you find out the dot product of these two vectors? Fine. So what are we supposed to do? Look at closely the values of I, the components of I, j and k in order you will consider. So how will you start writing the answer for this? It is ax times bx plus ay times by plus az times bz. Don't you think it is very similar to sigma? I is equal to 1 to n ai bi. It takes the general form, right? So that is why we wrote that formula first. So what is the answer, children? Tell me what is the answer for vector A dot vector B. Go and substitute the values based on the given vectors that you have on the screen. So ax bx would be, I hope you're getting minus 2, and then plus 3 plus 2. And what is the answer? So it is going to be 3. So the dot product of these two vectors A dot B is going to give you 3. So the answer is 3 ultimately. Okay. And that's how you evaluate the value of dot product of any two vectors. Okay, so I hope this is clear. That's the method of identifying the dot product. Suppose you want to find out the angle, you can make use of the second formula, right, as I told you. So based on what is asked, corresponding formulas are used. Okay, I'll give you another question. Next question, second question, you can try. Next example. Calculate the angle between the vectors. Okay, calculate the angle between the vectors. So I'm giving you the vectors now. Say vector A equals I plus j plus k. Okay, this is vector A. And I'm giving another vector. Vector B is equal to minus 2i minus 2j, okay, minus 2k. Fine. So you have two vectors, children. So what do you think will be the angle between these two vectors? How do you find out the angle? Okay, make use of the second formula because the second formula relates the angle basically. So what is the second formula that we learned? It was vector A dot vector B equals to modulus of A times modulus of B into cos theta. Okay, so you can make use of this relation and find out what is the angle theta. So you rearrange for cos theta, make cos theta the subject. So what is cos theta equal to? It's the dot product of both the vectors A and B upon the modulus of A times modulus of B. Okay, that's it. Now go and substitute the dot product. So for dot product, you need to find out the dot of both the vectors. So in the numerator, what do you have? It is minus 2, and minus 2. The whole upon modulus of A. What is modulus of A? I hope you're getting under root 3 for vector A modulus, and for B modulus, you get under root of, so 2 squared plus 2 squared plus, 2 squared, I mean minus 2 the whole squared. So how much is that? You're getting 12, right? So you get the value as 12. Okay, simplify it, you get minus 6 upon, yeah. So here you have root 3 times root 12. You can write it in terms of the simplified version. Extract, do prime factorization. Can be written as 2 root 3, right? You can write it as 2 root 3 because 12 is 4 3s are, and 4 comes out of the root as 2. Okay, so it can be expressed as 2 root 3. So 2 1s are, 2 3s are. So finally, how can you express it? The answer. So you can write it as minus 3 upon root 3 times root 3 is 3. So gets cancelled, you get minus 1. So if cos theta is minus 1, what is the angle of theta? I hope in mathematics you would have learned. So theta is cos inverse of 1, minus 1. So for what value of theta is, cos value going to be negative 1? So theta will be equal to 180 degrees. Okay, so that's the angle of theta. That's how you find out the angle theta in this case. Okay, so this is the method, children, to find out the angle between any two vectors. So you relate by using the formula of dot product, which tells you vector A dot vector B is equal to modulus of A times modulus of B times cos theta. So substitute, children, in this formula. Be very careful. Substitute, simplify it, and then in the final step you will find out what is the angle as I have done. So this is the methodology to solve this question. I hope it is clear how to calculate the angle between any two vectors. Okay, this is the general method of doing it. Okay, so this is evaluation of the angle. By using the dot product relation, we have successfully found out what is the angle between any two vectors. Okay, so any doubts here so far, please answer. Please, you can ask. Feel free to ask the doubts and get it clarified in case you have any. Okay, so next we are moving on to the next concepts. So there are so many concepts involved, in vectors. So that's the reason I'm asking. In case you're stuck somewhere or you feel that something needs to be explained, you can definitely ask. Okay, otherwise we can proceed further. Okay, I hope it is clear, children. The dot product, scalar dot product is done. So we have now learned about scalar dot product, how to find out the dot product of two vectors, how to also evaluate the angle between two vectors in a scalar dot product is what we have done so far. Okay, so with this we'll move on to the next aspect. So the next number is 7. So moving on to the 7th concept for the day. Okay, next we have vector cross product. So now we are going to see vector cross product, children. Okay, so how to evaluate vector cross product? Let us see. Okay, how to do that. So when I say vector cross product, so we, instead of putting a dot, we generally represent it using a cross. Okay, so whenever you have two vectors A and B, you can find out their vector cross product by using a particular relationship. So I'll tell you. Here is just not the algebraic method. The method is totally different. It's a different aspect, altogether. Okay, so when I have two vectors, so say A and B, say this is vector A and this is vector B, and okay, the cross of these two vectors, the cross product of these two vectors will give me a third vector that is perpendicular. It's mutually perpendicular to both A and B. So it is in this particular direction. So this is A cross B. Okay, so a vector cross product of two vectors A and B is defined as the vector which is mutually perpendicular to A and B, and it is directed along the axis, okay, perpendicular axis or containing both the vectors A and B, and that is how the vector cross product is determined. So let us see what is the formula for vector cross product. So if I say vector A cross vector B, how do I calculate the cross product of these two vectors? Okay, let us see that. So what I will do here, I will take I, J, K in order. First I am writing the unit normal vectors in order, and then the component of vector A should be written in the next row. The first row I have the unit vectors. Second row, components of vector A, which is AX, AY, AZ. Next you have components of vector B as the third row, which is BX, BY, and BZ. So these are the components of both vectors A and B taken in order as the second and the third row respectively. We have to find out the determinant of this matrix. We have formed a matrix containing 3 rows and 3 columns. So you have to evaluate the determinant. So I'll be teaching you how to find out the determinant of a given matrix. So you need to take alternating signs on the top, children, plus, minus, and plus. So now let us try to evaluate what is A cross B. Okay. So let us start. So first you start with I. You can see what is the sign above I? It is positive. So it is plus I. You need to open the bracket. The corresponding row and column to be blocked. I repeat, you block the corresponding row and column containing I cap. When I block, can you see that there is a 2 cross 2 matrix inside? right? So you will go downwards and multiply. I repeat, you will go downwards and first multiply. And what are you getting in the process? AY, BZ. As you go upwards, you will subtract. I repeat, as you go upwards, you will now subtract, which is minus BY AZ. Close the bracket. That is how you evaluate the vector cross product for the first part. For the I, we have done. Okay, so what did we do? First, we wrote the sign above I, which is plus. So plus I. Then we opened the bracket. We blocked the corresponding row and column containing I. We were left with a 2 cross 2 matrix inside, a 2 by 2. And then as we go down, we multiplied and we wrote the value. But as we went up, we subtract and then wrote the product of both. So going downwards, multiply and write it first, and going upwards, subtract and then write the product. So that is a rule that you will have to follow. Am I clear? I hope this aspect is clear to all of you. Same way, who can tell me what is the second element for J? What would you do? Look at the sign above J. It is not plus, it is minus. So minus J cap. Open the bracket. One of you can try. So you can tell me what will you write inside for J. When you try, you will get it, children. So what do I do first? So corresponding row and column containing J has to be blocked. So I block the corresponding row and column containing J. So what am I left with now? You're left with two different elements. AX, BZ. As you go downwards, take the product. So what happens now? You will write it as AX, BZ. As you go upwards, I told subtract and then write down the product. So minus BX, AZ. Done. And then you close the bracket. So that's how you do it for the second term. Okay. Now writing it for the last term. So that is for K cap. What is the sign, children? You can see above K, it is plus. So plus K cap. Open the bracket. Corresponding row and column of K needs to be blocked. So I block the corresponding row and column containing K, and you're left with a 2 cross 2. So AX, BY, as you go down, just write the product. As you go up, subtract and then write the product. So minus BX, AY. That's it. So this is how you find out the determinant of a given matrix. So if you have a 3 cross 3 matrix, so determinant should be found out like this. Okay, that's it, children. This is the method of evaluating the determinant. So I hope I am clear of how you will find out, the determinant in this particular case. So a cross product has to be evaluated by using a determinant method. Okay, so draw the matrix immediately and then you try to find out what is the cross product of two vectors. Okay, this is a formula for determinant by using, for a cross product of any two given vectors A and B. So I hope this is clear, children. Okay, I hope you have made a note of it. And now let us apply it to any particular question and let us try to evaluate the vector cross product. Okay, so let's try to apply it. Here comes an example. Calculate the vector cross product of, so I'm giving you two vectors. Vector P equals 3i minus j plus k. Vector Q, I plus 2j minus 2k. So you have two vectors P and Q. Okay, so you are supposed to find out the vector cross product of P and Q, which is P cross Q, to be evaluated. So how do you do that? By using the matrix method, you can do it efficiently. I told you first I, j and k to be written, and then you will have to write down the components of each vectors p and q in order as the second and the third row. So here below I you will have 3, below j minus 1, below k plus 1. This is for p. Next for q values as the third row, which is 1 plus 2 and minus 2. So we have formed the matrix. Okay, don't forget the alternating plus and minus sign. And now you go and calculate it. So first you have I, open the bracket, corresponding row column block it. So you will get 2 minus 2. Next minus j, open the bracket, close the corresponding row and column containing j. You will have minus 6, minus 1, and lastly plus k. You open the bracket, corresponding row containing k, okay, and row and column containing k to be blocked. So you will get 6 plus 1. Okay, so this is how efficiently you can do it. So first one it's 0, so you don't have I at all. The next one you will be getting the answer as, if you simplify, minus 6 minus 1 is minus 7, but minus times minus becomes plus, so ultimately you will get 7j. And then you will get plus 7k. You can take 7 as common. 7 times j plus k, and that's your answer. So p cross q, we have calculated the cross product as, so you can write therefore p cross q equals 7 times j plus k, and that's the answer. Okay, I hope it's clear, children. This is the method to calculate the vector cross product. So efficiently we make use of, okay, the matrix method, or it is also called as the determinant method. In mathematics there is a separate branch called as determinants. So generally, you know, in grade 12 you would be learning it, okay, but physics demands you to know it to calculate the, you know, vector product, and that's the reason we have this concept right here. Okay, it's a simple concept. You understand the logic, children, of, you know, evaluating it. It is very simple, okay, but it requires practice. So this is the method you will have to do it. So this, out of practice, you know, you can be very fast, you know, in computing the vector cross product. It's not that difficult as well. Once you get the hang of it, it's quite simple. Okay, so just you need to, you know, do it once or twice so that you're confident enough to do it on your own. All right, so I hope vector cross product is clear. So we'll move on to the next part, shall we? So shall I scroll it down? So I hope you guys are clear with this. So on this we'll move on to the next aspect of cross product of vectors. Okay, so there is a formula for angle also. Determinant formula we have written. Now we'll go on to the next aspect. Okay, okay, here whenever you have two vectors and you try to evaluate the angle, okay, between those two vectors, so it is given by the relation. I'll give you vector A cross vector B equals, okay. Now here whenever you try to, you know, relate this cross product of vectors, okay, in terms of the angle, things are totally different, okay, as far as concerned. So here you will find out the vector cross product relating angle as modulus of vector A cross vector B, okay, is equal to modulus of vector A times modulus of vector B times sine theta. Okay, using this particular you know, relationship, so you can find out what is the angle. So rearranging for sine theta, you will be getting the value as sine theta equals modulus of vector A cross B. So A cross B mod itself you should find upon modulus of A times modulus of B. So by using this relationship, you can find out what is the angle theta. So what is theta then? It is sine inverse of this particular value. Okay, sine inverse of mod of A cross B upon mod A times mod B. Okay, that gives you the angle theta, children. That's it. Okay, so sine theta is going to relate for cross product. So you should keep that in mind. Okay. You can also find out what is the unit vector n cap here. Now that is also quite important in cross product. How to find out a vector that is, perpendicular to the both given vectors. How to find out the n cap. So here also there is again a relationship. So n cap is found out by vector A cross vector B upon modulus of vector A cross vector B. This is a formula to find out the unit vector of cross product of two vectors. So you can find out a unit vector containing the cross product of two vectors by using this particular relation. So these are the important aspects relating, the angle theta, as well as I've also given the relation for the unit vector of cross product of two vectors. Can be found out using this particular relationship. Okay, so I hope it is clear, children. So whenever you have two vectors, evaluating the cross product by using matrix method, and then we have seen the angle between two vectors during a vector cross product, how to relate them, how to find out the angle in terms of cross product, and finally the unit vector of cross product of any two given vectors can also be found out. Okay, so this is the concepts for vector cross product. Okay, so for vector cross products, so please keep this in this particular thing in mind. Okay, so this is the aspect, children. Even for unit normal vectors also, you should be knowing the rules here. Okay, so I taught you the determinant method, no doubt. Okay, so even for the unit normal vectors also, you should be aware of how to express them. So let us see. First, let us see I cross I. Okay, so you see here I cross I, J cross J, K cross K. What would be the values? You can itself tell me. Here you will apply the sine rule. So basically on sine theta you have to use that particular relation. So J cross J and K cross K. These values will give you 0, children. Okay, unlike there it gave you 1. Here it will give you 0. Because when you find out the sine angle between them, it's going to be 0. Because both of them are coinciding, the angle is 0. So sine 0 is 0, but cos 0 was 1. And that is the reason you got 1 there. Okay, so cross product of like unit normal vectors will fetch you and they will give you 0. But I cross J is not 0. I cross J is K. J cross K is I. Okay, and K cross I. K cross I will give you J. So whenever you take the unit normal vectors in order, it will give you the third vector. Okay, so generally we go like this: I, J, and say K. Okay, so when you have 3 unit normal vectors and you go in order, you take them in order, then it will I cross J will give you K. So keep that in mind. J cross K is I and K cross I is J. Okay, like this. So if I'm going in order, it will give you the third vector. But what if you go in the reverse order? What if you go from J towards I? J cross I will give you minus K. It will give you the negative. Similarly, I cross k will give you minus j, and k cross I will give you k cross j will give you minus I. So this also you must keep in mind. Okay. So the relation between the cross product of the unit normal vectors also we have now discussed. Okay. So I will write that here for reference. Okay. So j cross I gives you minus k, and I cross k gives minus j or negative j, and finally k cross j gives you minus I. That's it. So that's how you find out the cross product, okay, of vectors. So you know the cross product of unit normal vectors. What are the relation? When you take in order, how you express them as the third vector, and when you go out of order against the order, how you express them in terms of their negatives. So this is all about the unit normal vectors cross product. So we have we have learned so many aspects, okay, as far as the you know vectors are concerned. So vectors is basically a vast topic. So you will have to master these aspects of dot and cross product. So you will have to practice them well. Okay. So with this we will move on, children. I hope it is clear so far. Okay. So what are the relations between the vector cross product, the determinant method, how to calculate, and how you need to find out the angle between two vectors in cross product. We have seen how to find out sine theta, and we also learned how to find out the unit vector of cross product of any two given vectors, and finally the relation between the unit normal vectors also in cross product. So all this has been discussed thoroughly. So on that note, we'll proceed further. Okay. So we are done with the basics, and certain advanced, topics also in vectors I have covered. So with that, we'll move on to the next aspect. Okay. So next, let me see what is the number 8. Next concept number 8 for the day. Okay. Now we have something called as parallelogram law of vectors. So we will see what is that. Okay. So parallelogram law of vectors. This is quite simple, children. So what is meant by parallelogram law of vectors, and how do we evaluate the parallelogram law of vectors? Let us see. Suppose there are two vectors. Okay. So I'm just representing. I'm doing a freehand drawing. So put up with me. Suppose you have two vectors like this. Okay. Let me name first vector as P and second vector as Q. Okay. So whenever you have two vectors P and Q that make the adjacent sides of a parallelogram having an angle theta included between them, then the resultant of these two vectors, I repeat, the resultant of these two vectors is given by the diagonal of the parallelogram. Okay, the resultant of these two vectors is given by the diagonal of the parallelogram as shown in the figure. So this is the resultant, R. So you can find out R, which is given by the diagonal of the parallelogram. And R makes an angle of, say, alpha with one of the vectors. With Q, it is making an angle of alpha. Okay. So having this figure, you can find out what is R, what is the value of resultant. By parallelogram law, we can say that resultant is given by the relation under root P squared, okay, vector P squared plus Q squared plus 2PQ cos theta. Okay. So that is how you can calculate what is the resultant of these two vectors. So this is the method to calculate the resultant, and wherein theta is the angle between P and Q. Okay. So I'll write it here. Theta is angle between P and Q. Okay. So in by parallelogram, what do you understand? If vector P and Q are the adjacent sides of a parallelogram, then their resultant is given by the diagonal of the parallelogram. Okay, it's given by the diagonal of the parallelogram. That's it. So that's how parallelogram law of vectors can be effectively used to calculate the resultant of any two vectors. Okay, considering them that they make the adjacent sides of the parallelogram. Okay, so that's how you calculate the resultant. So resultant is given by this particular relation. R is equal to, you can say, under root of, say, a squared plus b squared plus 2ab cos theta. You can use this formula also if a and b are going to be the adjacent sides of the parallelogram. Similarly, you can find out what is the direction of resultant. Okay, that is also having a relation. So direction of resultant is given by tan alpha is equal to, so previously I took P and Q, I will write for that. Okay, so you can write this as Q sine theta divided by P plus Q cos theta. So like this, you can find out the direction of resultant, which is given by tan alpha. So generally it is alpha. So when you take alpha, alpha is tan inverse. It gives you the direction of resultant as tan inverse of Q sine theta upon P plus Q cos theta, if P and Q are adjacent sides. Or you can also write it as, if A and B are the adjacent sides, how do you write the same formula? You will write it as B sine theta divided by A plus B cos theta. That's it. So like this, you can find out the direction of resultant in parallelogram law of vectors. So this is the direction of resultant in parallelogram law of vectors. I hope it is clear. So this is all about the parallelogram law of vectors. So if suppose you have two vectors which make up the adjacent sides of a parallelogram, having an angle theta included between them, then you can see that the resultant of those two vectors is given by R using the formula under root of sum of the squares of them plus 2pq cos theta. Okay, under root. So that will give you the resultant. Similarly, alpha is given by the direction. So alpha is tan inverse of p sine theta upon a plus b cos theta. Okay, so this is all about the parallelogram rule or parallelogram law, however you call it. Okay, so I hope this aspect is also clear, children, to all of you. Okay, so fine, ensure that you work on this. Okay, so we have seen what are parallelogram law also, so we have covered. Fine, so there are questions based on this also. Okay, so let's see some questions also, and then we will wind up. So let me know, I will not take too long. So let us see some questions based on this. Okay, examples. Okay, here comes the question. Yeah, calculate the resultant the vectors given below. Okay, calculate the resultant of the vectors given below. So here is a diagram, children. So they have given you the vectors along x and y axis. So this is an axis. So it's basically the first quadrant. Okay, so x and y. So let me just mark it for your reference. So this is y axis on the top, vertical axis, and horizontal axis x. Okay, here comes the question. So you have two vectors like this. Okay, so like this you have two vectors. Now the values of the vectors have been given here. Okay, so they're giving you the values itself of the vectors. So one of them is 25 newtons. The force vectors are given. The other one is 30 newtons. Okay, 25 and you have 30 newtons. Or we will take small numbers to make things simple. So say this is 5 newtons. Okay, and this is the other one. We will take it as 8 newtons. Okay, so there are two vectors, 5 and 8 newtons. Now the angles have been given. Carefully you see the angle of 5 newtons along with y-axis is given as say 30 degrees. Okay, and here also the angle made with 8 newton force, okay, with say the x-axis. This angle has been given, children, and this angle is given as 10 degrees. Okay, so these are the angles given. Now the question is, you will have to calculate what is the resultant of these two vectors. So vector r has to be evaluated. And how do you do it? How to find out vector r? For that, first you should find out what is the angle between those two vectors. Right? We don't have angle between them. But you can find out the angle between them. Anybody? What is the angle between vectors 5 Newton and 8 Newtons? From the figure, can you calculate? Okay, one of you is giving. It's better that you unmute yourself and tell. Yeah, 50 is right. Good. So it's 50. I hope you know how to calculate that. The total angle between the quadrants is 90. So 90 minus 40 will fetch you 50. So it is 50 degrees basically. So vector r is given by under root of 5 squared, which is 5 5s are 25, plus 8 squared 64, plus 2 times 5 times 8, 2ab cos theta. It's of that form, right? So 2 times 5 times 8 times cos 50 degrees. Okay, that's it, and you need to simplify it. Okay, so once you simplify it, you will get the particular answer for the resultant. Okay, I just want you to know that you should be aware about the method of evaluating. Generally 50 will not come. Okay, it might be any particular value out of, say, it can be 15 multiples of 15 possible. It can be multiples of 30 or multiples of 60. So like that you will get. Okay, 50 rarely they ask. I mean, they don't even ask 50 generally. Fine. So that's how you need to apply. This was just a question that I framed on the spot. So this is how you calculate the resultant of any two vectors by applying the parallelogram law of vectors. Same thing if I ask you the direction of resultant, what would you do? You need to find out what is alpha. So alpha is equal to, now you will apply 8 into, so you know that it is b cos theta, so 8 cos 50 divided by 5 plus 8 sin 50. So on evaluating this, you will get the value of alpha, children. Okay, that is the direction of resultant you can find out using this particular relation. Okay, so this is the method to calculate what is the resultant of any two vectors for parallelogram law and the direction of any two vectors by using parallelogram. That is the direction of resultant basically. Okay, the direction of resultant you can find out. So that's how you do it. So now the session is open for any doubts, clarification. So if you have any doubts, you can ask them, you can clarify, we can discuss. Anywhere you're stuck also you can ask. Okay, I hope it was clear. I didn't go too fast. So because I took my own time, and I ensured that everybody is being able to catch up to the pace. Okay, so because it's a crucial topic, so it's necessary that all of you go through it, make notes whenever possible based on the topics, and then you can start preparing. Okay, so I hope it was clear for today's concepts. So yeah, you can now, the forum is open for doubts, clarification, or you want something to be explained, or somewhere you're stuck, you can ask. Okay, otherwise you can even post it on WhatsApp. Fine. So feel free to communicate in case there are any queries. So with that, we can wind up, children. If you have any doubts, you can ask. Okay, welcome. You're welcome. So I hope that's it. All right, children. So I hope it was very useful, and you have made notes wherever possible. Okay. So once again, we will catch up another interesting session. So until then, see you all. Okay. Bye bye. Take care.
Okay, Manish.
Okay, uncle.